Hello everyone and welcome back to another live stream. Today is Friday and I've decided to not wear my business shirt, but that's okay. White is the color. And today we're going to be going over a few things. Going through the file service files, which is basically where people will upload different files to me for certain things, right? Like whether they want tunes or map packs and all those sorts of things. And so the first one that we're working with anyways is a Suzuki Jimny, and this particular customer of mine is putting a turbo conversion kit on it. So if it is the MED17 ECU, which it seems to be, then we can help with this, and I'll make a map pack that this customer needs for all the maps for a turbo swap. Then secondly, we're going to be working on a Mercedes-Benz A45S W177, and we will be doing the patch, or at least seeing if it's required for some different wastegate control systems or logic for the open loop closed loop, and just making a little bit more how to say this, like, accurate for tuning and calibrating. So we want like either a bigger map, or we want something that's going to give, I guess, more of like a feed forward situation where you can have a target wastegate or some derivative of target wastegate, and then you're having more of a predictable outcome on the other end of it. Anyway, so the first thing we're going to do is we're going to go ahead and bring this in. So I don't think I've downloaded it yet, so download the file. Pull this across into WinOLS, and we will see if we have anything similar. As you can see, we don't right now. That's okay. We're going to go ahead and pre-populate this, and MED17 9.64. There we go. Finish. Okay, so now I'm going to go make sure all the maps are there, which they appear to be. It looks like a virtual read file because it's missing the processor data area. That's fine. All ECUs, and I should have a, there we go. That looks like it's pretty much what we need, right? That map pack there. Gonna connect the windows and see how similar they are. There are some similarities, I suppose you could say. Start from here. I'm just gonna copy everything across. Maybe it's the same for that, maybe it's not. Doesn't look like it is. I'm gonna go back up to here. Transfer that. Transfer nothing. Cool. Let's see if that has any similarities between the two. Okay. Very, very similar to what we're looking for. Okay, get us some of the DTCs. There we go. See what else we got. Got all these. There we go. There are some minute differences, so I can't Can't say for certain whether or not what's on the left-hand side and the right-hand side is the same, because it's all pretty much the same value. If you have a look here, that looks to be there, so probably going to go up until where at least it's continuing to match. Let's see if I go like that, for example. That then starts matching. I'm actually not gonna transfer a lot of that because I can't say for certain whether or not it's the same. So what I might do, I might actually just start off by, let's remove all of that. Let's not worry about that right now because I don't want to be transferring values that I can't be certain that that's what they are, right? It's not the right thing to be doing. I'll give him everything I can with this stuff because that's all the same. It's actually quite interesting to me how similar software versions are. Usually for naturally aspirated cars it is like this, it's quite similar between software versions. And I guess on something like a Suzuki Jimny, there wouldn't be a lot of money thrown at the ECU development side of it from Suzuki, I would just imagine, compared to something like Mercedes or Porsche, you know, for example. Transferring all the maps from the right hand side to the left hand side. It's incredible. Look at this. It's just all pretty much matching the entire way down. There's a little bit of different data, like in different values in here, but nothing that I would say is important for what we're trying to do. I'm basically just copying across all the maps so long as the data matches. Look at that. It just continues to match all the way down. Makes things really easy for me because I've already done all the hard work. It's basically just transferring across all the values now at this point. Look at that. Just it continues to be the same all the way. That's incredible. What about this? This is our gearbox torque limitation, or torque limitation based on gear. Right, that's all pretty much done. Incredible. It's so similar between these two software versions. What is that? That's definitely not correct. So if I go to the so it definitely does need the axes to be different. Yes. Let's just hope that's not in a map again. I don't know why that would have been. Okay, that's better. Cool. Okay. So the only... Is that literally everything that quick? We have VMAX here, that's not on the other one. Torque pedal, monitoring 8. So that's 14 in this one. Okay, so we've got all that. Okay, this one needs to be transferred across. And what have we got now? We've got 14. Temp 4. Gearbox 13. Yeah, there were 2 missing maps, but they weren't interesting to me. Torque and load got it. 4, 4, 14. Yep. 279. 279. 468. 468. 499. 28. 1, 2, 44. Oh, we don't have them. That's fine. 44, 4, and 10, and 9. Yeah, that's pretty much everything. That's all the maps that we needed, with the exception, obviously, of the error codes. What I might do, I might just transfer across some of the more important error codes, or at least what, you know, maybe the cat example. Let's have a look. Or cat, is it? Shouldn't be in German. Maybe it is. Okay, let's have a look at this. 5, 5, it's not there. Yep, that's definitely the right one there. Yep. Yep. Okay. I might just keep that there, and that should be enough, I think, for this. So some of the things that we need, being a turbo conversion kit, are we need some of the pressure sensor scaling, a lot of the fuel pressure stuff, but being this is not a direct injection engine, you won't have your high pressure. So let's have a look. I might actually open up the Suzuki, the Damos, and go through that and see if there's anything we can find. There we go. Which is a 1.5 as well, thank goodness. So if we got the boost, we've got the air, let's have a look. Pressure sensor stuff. Sensor pressure, upper and lower. We have the gradient of the pressure sensor, all that, that's very important. Let's see if there's anything for fuel pressure, for the low pressure. Pressure, fuel, let's have a look. Nothing really. Pump. No. There you go, pretty simple car. Sometimes they just are, you know. Sometimes they just are. I might do some of the left foot braking maps. Transfer some, look at that, that's incredible how similar that is. Threshold vehicle speed check. We also want the engine speed. Transfer select maps. Did we already have them? No, we didn't. There we go. Left foot braking. We already did have a left foot braking. Oh no, left foot braking. We didn't. Put them in that folder. Left foot braking. Cool. Okay, that's there. That's cool. What else might we need? Going through all of this. I guess we can do some of the fuel, like the overrun fueling stuff, if this customer decides that he wants to do that. Or have we already got it? We've already got it all. Okay, we're just going to go with that because it seems to all be there. If he needs anything, he'll just let me know and I can just add it for him. Correct now. Nope. Okay, if we go ahead and correct and export this. form, and then we go to here. We're going to then zip it up at archive as a zip, and then upload it to that gentleman there. The next thing, as I said, is we're going to be working on the A45S, which is somewhere here. Did I delete it already? I may have deleted it accidentally. We'll go back. And if you like, by the way, guys, use the chat. Ask me some questions if you have any. I'll answer them throughout the video. Just give me a sec. I'm just going to download this file real quick. I just don't want you seeing where it's coming from to protect the guy who I'm getting it from. Cool beans. All right, I'm back. So let's go download this into here. Let's have a look. We've got 85,406 maps, so it's an 80% similar to the demo. So it's pretty much the exact same, at least calibration area wise. Let's have a look. Cool. Loading this file in, and we're going to be trying to work with the boost control system in this to try and make it a bit better. So there's 3 different ways that you can control boost, usually with Mercedes-Benz Med 17 MG1. That's open loop with the pedal position and engine speed axes. And then you have a target wastegate duty cycle in the map, right? This is set by an application parameter, usually named, where is it? It's in here. Code word for the application of the torque function or torque structure. So with this particular code word, we turn this on, and we then have the ability to use the open loop control system, and it bypasses the entire closed loop control system for this A45S. But we're not going to be doing that. The second way that we can control it is usually with a module called BG hat, but it doesn't look like it has that. Let's have a look. Boost control P governor. So there we go. BG Hut. Sometimes, depending on the software version, depending on the ECU, will be named different things. But this is essentially the same map here. So map for the position of the boost pressure regulator. Okay, and that's the closed loop feed forward wastegate control system map. Then you've got the application map as well for this particular module. So what we're looking for is somewhere around here. Where are you? Is this the one we're after? Yes, I think that's the one we're after. Okay. So with this, what we can do, I have it in my course when I recently uploaded it. I called it the secret way that Mercedes-Benz, you can control boost pressure, then all that sort of stuff. The way that we do it is in this map here, we have the axes of engine speed, and we also have the other axis of boost pressure before the throttle, I think it is. It's just boost pressure. Let's just say it's absolute boost pressure, right? And in the map, we have, well, it's asking for a HPA variable, right? So that's pressure. And essentially what this map does, it's not turned on from factory, you actually have to turn it on, is you put in a pressure value that translates to the position of the wastegate. And the way that you find that is by this map here. So you've got here pressure that's going through the wastegate, and then you've got, as a function of pressure through the wastegate, you've got a target or a position of the wastegate actuator, right? So obviously, depending on the position of the wastegate, depends on how open the wastegate flap is, depends on how much pressure is deviated through that hole, which then, this particular model in this ECU uses pressure past the wastegate to then figure out position, or at least modeled, right? Nevertheless, what we can do is we can use this map by putting in a pressure value, like from -0 to really to -800, and that'll give us a wastegate position, that's a result of this, right? That we can use. Instead of using this one here, which is based on some maybe back pressure variable and also mass airflow through the wastegate, something like that, we can actually use this map here. So one of the ways that we need to do that though is obviously we need to actually turn on this function. And what I'm going to do, I'm going to go through the document that will help me with this. So if I go Mercedes, got to download it. Love that every time. And then I can sort of figure out the logic and see how to turn it on. But the thing is, I'm curious to know, it might need some patch because it doesn't even look like it's on even in the normal system. So I'm wondering if there's another map that takes over this function somewhere else, right? Because very interesting to see that we've got another wastegate position map. We got two of them, do we? Let's have a look. We might be limited to using what's here. We might have to just use this module. But we'll have a look, right? We'll have a look. We'll see how we're going. After this is finished downloading to my computer. If you have any questions, guys, like I said, put it in the chat and I will answer them to the best that I can. You'll see it on YouTube that there should be a YouTube chat. You're more than welcome to ask anything and I will try and reply to you. All right, that's finished downloading. Let's see if I can put that anywhere. FR. Obviously, I keep things on a drive for security reasons, right? I don't want my stuff getting stolen, and it happens. It really does. Okay, so this module here is the BGLDR STG. BGL. Let's have a look. Functions. BG. I hate how I forget this stuff, eh? I literally just looked at it. BGLDR. It's not here, which tells me that it's not active at all. Okay. What we can do then is, I'm wondering if it's not even active, is all of this data even used? Like all of these maps? Because often I wonder if you zeroed all of this out, right? If you literally completely zeroed it, including the axes, which usually you definitely would never do. I'm wondering if anything would happen because there's nothing in the FR about it, and the customer of mine who says this function's not working at all says that he thinks it's not even turned on. Now I'm wondering if the application code for it even exists. You know, that is something that interests me. But maybe what we can do instead is we can have a look at this application map that, yeah, I definitely got to set that back to the way it was. Oops. There we go. Okay, that's better. Maybe the application map we can change in this module here. Because you'll see here, right? Application mode. And that's based on boost. Yep, and that's based on engine speed. So let's have a look at this one. And that's in the boost control model boost. Have a look if that's even in here. Hopefully it is, right? We'll just have a look. Try and find this map. See if we can see anything about how it works, right? Okay. Here we go. Boost control, feed forward, awesome. And depending on this map here, the bit position 0 will turn it on. So if we go to this map, boom, boom, that turns this map on, which then is also affected by this map here. Okay, so that's 1 times that, take that, equals the output message. And then we've also got this here. What's that? Okay. We've got two different variables here. Okay. Let's have a look. Always very interesting, in my opinion, to read this sort of stuff. Try and figure out what it means. Okay, application mode for the wastegate stroke is activated. The bits can be activated using the code word. Okay. Yep. Cool. All right, that's all fine. Right, so that's this here. So there's two different systems we can use. We can use one based on pedal position and engine speed for a wastegate position, or we can use boost pressure and engine speed, which I think we're going to end up doing. I think, personally, that's the way to go about things, is to use this map here and this map here for our target wastegate. That just seems to me like a much better system, right? Much better system. So what I'm going to do, I'm just going to, because this guy already knows what he's doing really well, I'm just going to edit these two, or I might even just export these two maps. Export map pack, selected maps, closed loop feed forward. Okay, and we'll then export this actual file. Don't worry about that. Feed forward, boost RPM. Oh, definitely not as an Intel and hex. Binary, feed forward, boost RPM, .bin. Cool, and I might even take a picture of the logic for him so he understands how it works, right? Let's do that together. So if we go Control Shift, Control Alt, the logic, so he can see it works, yeah, and he can calibrate as he likes. But I like teaching people, you know, like there's no point not teaching someone how something works if I understand it. So obviously I'm just going to highlight this for him. And set this, so that's 0, 0, and that's 1. Cool. All right. And then I don't know if I can write some text in there. That's okay. Doesn't really need to be done. 1. Turns on logic. There we go. All right. I'm going to copy that. I'm going to just, are you accessing this document through a service you pay for? No. No, I'm not. Just be a sec. I'm just going to send this back to him. I don't want to disclose who he is for his own sake. Okay. Just sending it through to him. Be a second, guys. Alright, that seems like it is all good. Okay, and we're back. So I'm going to have a look through and see if there's any other things that we need to do in here or that I can remember. Not at the moment, that's fine. What we might have a look at then, so we've gone through the wastegate logic for the A45S, and as I said, turning on this particular byte allows us to use the feed forward system by this map based on engine speed and boost pressure. And then here is the map for the wastegate position, 1 being, I suppose, open, 0 being closed by the look of it, or no, I may be wrong there actually. Yeah, sorry, 0 is open, 1 is closed. What I can do, actually take out like 2 zeros out of the factor, and then that'll give me more of like an idea about the percentage wastegate that's being used, right? And then we can go ahead and use this map. This is a lot easier to use rather than something based on back pressure of the turbine and, you know, mass flow through the turbine. and then having a position based on that. This system, look, it's good. It works very well for a factory setup, but when you start putting big turbos on things, it's a lot easier to have a feed-forward system like this. It's just way easier to calibrate. So that's all pretty much done now. All good. So now maybe what I might do, I might have a look at some of the projects that I have in Ghidra. And I'm going to take all these away. I don't need them. And have a look through something that I might need to do with reverse engineering. See if I can teach you guys or show you guys some stuff. Like I said, you're more than welcome to ask things in the YouTube chat. I will answer you. But yeah, so Eric's asked, am I accessing the documentation through a service I pay for? No. Usually documentation is online for the public to download if you look hard enough. That's usually how people get it. So we were working on the Ferrari yesterday. We can continue looking at it, but to be honest with you, I don't think that I can get too far with it from where I already am, because I need some further information about the location of a particular RAM variable. So I'm trying to get some information about that so I can then hook into the cluster. What I might work on though is the, let's have a look. I'm just trying to think, maybe the Amarok, hey? If I start having a look at the Amarok and see if I can start writing the multi-map or finishing the multi-map for that. CP4, 30 days, Amarok. There it is. So we've got, cool, we've got open version. Might open the Damos as well while we're at it. Cool. Connect the two windows together. Fantastic. So what we're trying to do is I'm trying to hook into these maps here, which are the maximum torque for eco or normal mode based on low gear or high gear, okay? And they will naturally switch depending on this variable here, which is the power class. A power class determines what exactly it sounds like, what power class a vehicle is. So if you think something in like simple terms, Audi now have like the 25, 35, 40, 45 TFSI or what a TSI. Think of it like that. The power class is a certain group of vehicles that this particular software version fits in, and it might be in Audi's software side of things, instead of being like a 45, 55 TFSI in the same power class, they would just call that power class 3 as an example. And it groups the vehicles around that same sort of power in there, and the power class can be used to actually change obviously the power and torque settings, or the power and torque production of the engine. And anyway, so what I'm doing is I'm going to go through this, and usually power class is between 0 and 3. So given that we've got 4 maps, I'm actually going to go ahead and do that in here, right? I'm going to go ahead and you can see it's got power class 0, power class 1, power class 2, power class 3. So what I'm going to do, instead of loading a byte D15 of the power class in, I'm going to load the map switch map state. So what current selected map we have, right? And see how we go with that. So I just want to go back up through the logic and make sure that we're looking at the right place. Yeah, okay, so there it is there. So I'm going to put that in. So what we'll do, I'll go hook, power class, torque. All right. Actually, I might make that torque eco, because that's what it is. Torque eco. Fantastic. And we will go to where our map switch function is, which is here. And I'm going to write here, map switch torque eco curve. Okay, map switch, cool, and then I'm going to call this address. So go back to here, I'm going to go edit this, address there. So now we just need to make sure, right, D15, I go plate comment, 15 returns value of map switch map, cool, just so I know that the return variable from this function needs to be D15, which needs to be a value of 0 to 3. Okay, and that's depending on the current map that we have. So what I usually like to do from here is do something like this, right? we'll check the current map state. I also need to check the A15 isn't used. Okay, A15 isn't used. That's really good for us. So I can go ahead and paste this in here, right? I can go this, and then I can go load bytes D15. That's pretty much all we need, actually. We don't even need all of that. Then I can just go return, and then the rest of it can all be no operation. So we go in here. It's just cool, save. So it's coming in, it's taking the value of the map switch map, and it's returning, and then D15 is the returned value, which then gets through all the logic. So that is honestly, it's that simple. That means that now these torque maps will be switching based on our map state rather than power class. Okay. There's also a few other ones here as well. We have the max torque sport, which is just our normal maximum torque. And so I'm going to try and find this. And the way that I would have to do that is I have to find these variables and then this map here. So look, TQ lim MP. What's this one here? Torque low gear. Maybe I was actually switching these. That's what I was doing. Max torque sport, power class 1, power class 2, power class 3. Okay. These ones here depend on EPM and ENG as well. I might have to go ahead and have a look at what function these are in again. So COPT torque calc. Let's go into that. No one's asked any more questions. All good. Okay. Let's have a look. So COPT torque calc. COP. Boom. There we are. So we're going to look for this map. There we go. And we've got what looks to be this map here. Okay, and we've got a function description as well, which is really nice. It's nice to have those things, right? Depending on the motor class determined by that, and whether reduction is on or not, the torque limitation is updated with the curve for reduction of the normal curve. Cool. No worries. Okay. So torque, low gear and high gear is used as a default value. Cool. Fantastic. No worries. So that's all good. I'm just going to try and see if this is actually a variable in the RAM or not. Maybe if I go just that, hey? See if we got... efficiency mode, that might be active, I could be wrong. Efficiency mode capping, and that's Newton meters, and I'm guessing that is a result of that map that we just looked at. So if we have a look at this, and that's at 762, what we're going to need to do is we're going to need to open the reverse engineered file, compare these two, hey? So was it 762, was that it? It was B000 762. Cool. We're going to go to where it's written to, and we're going to try and find the matching part in the hex between these two and see if we can find something. I love that. I love that. If you guys watch my Ferrari reverse engineering video, you'll know how bloody hard it is to find things sometimes. And like matches like this are really good for me because it saves so much damn time. 14744C 147C. There we go. There is our value, right? Right there. That's very nice. RAM, save that. And a few cases here. Look at this. Derived engine speed, and I'm sure there'll be something about power class here. Look, there it is. Boom. Fantastic. Okay, so now what we can do is we can... Let me just make sure A50... Okay, good. Okay, that's fine. A15. I just need to make sure if I'm using A15, which is the address register to hold the value of the address. To do the calculations, it isn't going to mess up the program flow if A15 is used again. See, A4 is there, so I could use A4 instead of A15. That might work for us. So we're going to hook, and we're going to go power class torque main. Okay, and then we're going to go back to the map switch. Okay, I'm going to go nop. Torque. Power class torque main. Okay, actually map switch. Boom. I'm going to copy the address and then jump to that address, and then I'm going to use A4 to do the calculations for the... Okay, so cool. We're going to work with this. So come in. I'm going to copy literally this program flow logic here. Boom. Take all that out. Paste that in. Except instead of A15, like I said, I'm going to use A4 only because I know A4 isn't going to mess up the flow. A4, A4, A4. Boom. Return. D15. Cool. All right. That should now allow us to use the maps here. Now A9, FO4, A9. Let's have a look. We've got A4 here, 70 to 9A. Let's have a look at the difference between this. We're trying to find the addresses that are going to be used. 9A takes 70. That's a difference of 2A, which is great. So let's have a look at the difference between these two. For example, if we go 3781 EE, 3781 EE plus... Actually, no, I'll do it the other way around. I'll go 378218, 378218, take 3781 EE. That definitely did not work. 378218. Take 3781 EE, was it? 2A, yeah, okay, cool. So that means that it is referencing these maps here. That's good for me to know, right? And A4 would be the start of the function, which would be... Well, really, it should be this map here. So that should be the start. So really, this value of 3 here, which is the size of the map, will be that address there with FO4. That plus a value of 70. So let's have a look. 1A8 plus 70 should give us 218, which does that take us? Boom, that takes us here. So 218, that map there is this one here. That's end of line comment. That's that map there. And obviously, depending, yeah. So, and then that's the first map there, which is this one here. So that's power class 0, which is fine. It's pretty much exactly what they said it was going to be. Do you see how this is working? It's pretty cool. Like, I like going through this stuff and sort of figuring it out. It takes a long time to get to this point, let me tell you. But at least we're getting through it, right? Okay. Cool, and that should be that one there. And then this one. Yeah, okay, so that's the last of the high gear for power class 4. Boom, how good's that? Okay, so we've pretty much found it. D15 then would, yeah, so these are the next 4 based on low gear. So they're all your high gear maps, and they're all your torque low gear maps. and then D15 takes on some other value down there, and then the logic changes. But what we're going to do for now is if we close that off, I'm going to export these maps here, right? So export map pack, all selected maps, map switch maps, Amarok. Save that. Then I'm going to export the patch that I've made. So I've got O for, is it O? Is that what I pressed? Yeah, it is. O, raw bytes, okay. And then we're going to pull that in from our downloads folder, finish immediately, connect the two windows. And now we go through where the references are. So if I just go to this address in the code, you'll see here there's a little change of bytes. I'm going to make that the same as the right hand side. And then I'm going to go and call that boom, book. Fantastic. And then there's also this hook here, which is different. Okay, then we're going to call that book, boom. And now the actual code, which changes the reference from power class to the current selected map, like that. Boom. Okay. It's actually saved as boost switching, even though we haven't got boost switching yet. But what I usually like to do now is export this file and go Amarok multi-map talk maps switching only. Save. And then I'm going to close this down because I got to wait for a response on that. Close that down. Don't need to use that for right now, but basically instead of power class, we're now using the multi-map map. Okay. That was Amarok, and then we're going to go to my customer with the Amarok. Few files here, bloody hell. There we go. And deliver this to him, and then wait for a response. And it's pretty much that easy. Yeah. Does anyone have any more questions before I end it? I might end it here. Only 47 minutes today, but, you know, I don't have a lot of other things to do right now. But I'll wait a minute if you guys have anything you want to ask. And, yeah, like I said, use the YouTube chat, and I'll let you know if there's anything I can help with. Alright guys, I suppose that's everything. We'll catch up soon, and yeah, send messages through if you have any questions, or an email through, and we can go over a few things. See you later.